that I'm circling with my mouse. The tip is getting more and more in focus because we focused on the surface. And it's coming down to it. And now we begin scanning. So after changing some parameters, now we're doing a scan size of 10 microns, and you can see if you look at this window very carefully, though, and I'm circling the tip kind of moving back and forth over the sample, and now we're getting our scan coming up. And I can see that some of these grooves are going to be not quite vertical, so we can adjust our angle with this scan angle button. And you never know which way it's going to rotate. So let's try 10 degrees and see if that makes it better or worse. We want to get it as vertical as possible so that it's easiest to measure the distances between those peaks and troughs. On these images, the darker colors are topographically lower and the lighter colors are topographically higher. Okay, so I think that made it worse, so we're going to try -10 instead. Alright, that's looking much better, so I'm going to start it just scanning from the top now, since it's starting in the middle of the image, so we'll start seeing it come in down from the top. And you'll see at the bottom part of the window here, there's this graph that has the red and the blue. And these are a cross-section of the scan that you're seeing coming in. And it's scanning each line twice. So the first trace is the blue color, and then when it retraces, it's the red color. So to get ready to capture our image, I'm going to make sure it's going to be saving to the right place. And it's our class, spring 2020, so that's correct. And I'm going to give it another file name. We're just going to call it aluminum, 10 microns. That, and I'm going to get ready to capture. And when we capture, we'll just start from the bottom. Okay, so when you open up your data, this is what it's going to look like. We've got our image here in the main part of the window, and you can look at it in 2D, again with that color ramp showing you the highs and lows, the bars on the right, and then you could also look at it in 3D, which is kind of a nice way to visualize it, because you can move it around and really see those troughs and those peaks, and I'm pretty sure these bumps that we're seeing here are actual data that's stored on the CD, all of these bumps here on the tops of the peaks. And so you'll also notice that our sample was a little bit tilted as we were getting this data, so we can flatten it to make it more flat on that Z-axis using a flatten tool up here. It looks kind of like a roller brush. You order it, if it were to just be kind of the Z-axis was really high, flattening it to the 0th order would bring it down. You could see ours was kind of a linear pattern, so it's going to be a first order flattening we're going to need to do, and then you kind of go by polynomial. If it were curved or something, you go higher. So we're going to do a first order flattening and execute it. And you can see that already made our color ramp way better here. There's no gradient, and if we were to look at it in 3D, now we've got something that's much more even and accurate. So after that step, I'll go back to our 2D view. And we want to measure what the spacing of these grooves actually is. So to do that, I'm going to click on this button called Section. It's like the knife icon up at the top here. And this is going to allow me to draw a cross section. I'm going to draw it across all of my grooves, and I'm going to do it perpendicular to the linear features. I'm not going to go straight across because they're not totally straight up and down. So just going to do my best here, drawing it perpendicularly. And that's going to give me this cross section in the window on the right. And so you can see all of our peaks and grooves, and this is going to allow you to actually measure those. You can drag these little dashed lines around, and the numbers at the bottom of the screen in these colorful boxes will give you the distances horizontally, vertically, etc. between them. If you drag in from the left, from the left and right, you'll be able to get more colors to be able to do more measurements. You may decide you want to go from peak to peak, or the full width at half max, or measuring across all of them and dividing by the number of peaks and troughs you have. And the more lines you draw in, the more information you'll have populating this colorful box down in the bottom left. So kind of a nice tip on adjusting your color ramp, because you'll see we're going from negative 131 nanometers up to positive 164. We can make that go from 0 up. So if I right click on that color bar and click color scale, and then go to the second tab, modify data scale, I will check this checkbox underneath the histogram that says color bar scale relative to minimum data cursor. So that's going to start it down at the minimum, and then if we want to make this a nice round number at the top of our color scale, we can adjust some of these numbers. So I'm just going to adjust this negative 131.6 to negative 132, make that a rounder number, and then I'm just going to adjust this 164.79. Let's try 165 and see. Okay, that put us at 297, so let's try 168, and that put us at 300 at the top. So now that's nice and even and looks good. So I'll click OK, and now our color bar is a little bit more reasonable.